Okay, so let me start recording.
Recording in progress.
Okay, so good afternoon, guys. So now, so this week will be the last week that we are meeting online. I hope you have heard from your other lecturers or from the faculty. Yeah, most probably we will start. I mean, that's what we heard from the university. So, most probably we will start next week. I mean, we will have physical classes from next week onwards. So, from May, beginning of May. So now the plan is, so I will finish discussing the confidence interval estimation. And then I will start fundamentals of hypothesis testing. Basically, that's the last topic of this module, fundamental of hypothesis testing and the one sample test. And now, as we met online couple of weeks, so I decided to kind of give you small quizzes when we are, I mean, from next week onwards during a tutorial class. Okay. So now next week, you will have tutorial on Wednesdays. Usually you are having the tutorials on Wednesdays. So that means May 6th. Okay. So we will have the quizzes on campus. So you will have the first quiz. So we will take the marks of those quizzes as the CAs. I know there's one CA project. Usually this the CAs, the activities that group activities. I will assign that one beginning of May, and then you will have 1 month to kind of submit the solution for that one. But anyway, I just want to check whether you understand the concept that we have discussed so far, the concept or the topics that we have covered in the second section. So therefore, I'm going to give you the quizzes, like 30 minutes or 45 minutes quizzes. And we will have one more in-class test as well at the end of the May, because you will have the exam. I guess you are going to have the exam starting middle of June something. So therefore we have kind of, anyway, we have a whole May to kind of do a couple of assignments. So now next week, Wednesday, you will have 30 or 45 minute quiz, which is from the continuous distributions, because you haven't, I mean, that part we discussed. I think, yeah, we discussed this one also online. So therefore, you will have question from this continuous probability distribution. So this is this section, this is the topic, the first topic that I have discussed with you all. So therefore, I will give you, we will give you a question from the continuous probability distribution, type of sampling methods, and the sampling distribution. Okay. So basically, you will get a couple of maybe 3 or 2 questions from continuous probability distribution, types of sampling method, and the sampling distributions. Okay. So the first quiz, so therefore the first quiz will be based on the sampling and the sampling distributions node. Okay. And the tables, whatever the relevant kind of the tables, we will give you. And you need to understand for this, the first module, you will not be given any formulas or kind of the equations, because we have very kind of the very basics or very simple equations. Therefore, you need to remember those ones. But for your probability and the the second course, you will have a kind of formula sheet. But for this module, the first module, we will not provide, we will not give you any formula sheet. But C table, T table, whatever the statistical tables, we will provide those ones. Yeah, so then after so the second week of May, that means May 30th, then you will have another quiz based on the confidence interval estimation and so on. Okay. Then at the end of the at the end of May, then we will have the in class. Okay. I hope it's clear to you. Because I just want to kind of check whether you understand the materials that we have discussed so far. That's why we are giving you the quizzes, and we will take the marks of those quizzes as your continuous evaluation for the continuous assessment. Okay. And there won't be any makeup quizzes. So if you miss quiz, then that means you miss the marks for that quiz as well. Okay. I mean, if you have any kind of the valid reason like the medical leave, then that's fine. But you need to send us the evidence, at least the medical report. Other than that, we will not give you any makeup exams, okay, makeup quizzes. That's the policy when we are giving the makeup quizzes. So don't think that's kind of a very strict law. That's the way that we do when we are giving the quizzes. Okay, otherwise making quizzes again and again will be a kind of a hectic kind of thing, task. So therefore, yeah. So let us know if you if you're if you're unable to come, or if you're unable to join the attend the class with kind of the valid reason. Okay. Hari. So now I will start discussing the remaining part of this confidence interval estimation. And Ms. Uttara also discussed couple of the things, couple of the topics on this topic. So I will give you a kind of again overview on the topic that she has covered, and then we will move to the next, the new topic. Okay. And now these pop-up quizzes, these practice worksheets, please try to do those ones on your own. These are just kind of the practice assignments before your quizzes, before your assignments, before your whatever the in-class final exam. So try to do these ones. Okay, you will get kind of similar questions for the questions on in these pop-up quizzes and the practice worksheets. Okay. Hari, any questions that were there? No questions. Okay, so that's the plan for the coming month and the coming weeks. Okay. Hari, okay, so confidence interval estimation. Here, what we try to discuss here, or what we try to cover here. Now, we know we can kind of find a point estimation. Okay, so we have simply, we have two estimation methods. Let me write here, two estimation methods. First one is the point estimation. Second one is the interval estimation, or the confidence interval estimation. Okay, so now point estimation, under the point estimation, we try to give give a single value for a population parameter. Okay, simply let's say mu hat. So we use this to kind of denote this is a kind of estimated value. We use this mu hat. Okay, so we call this one as mu hat. Or you can think, let's say sigma hat. Okay, so anyway, so mu hat is, let's say, 4.5. So you see here, and in point estimation, we have just a one value as a kind of estimated value for the population parameter. But in the interval estimation, what we try to do, we try to give a kind of a range of values of kind of an interval. Okay. So for example, let's say mu hat, or here we use actually without this mu hat, sorry. instead of mu hat, actually, we use mu, originally mu. Simply mu is in between, or you can say actually, yeah, better to use mu hat, let's say. Yeah, mu hat usually, with the interval estimation, we don't use this mu hat. Yeah, better go with the usual notations. Okay, so mu is in between, let's say, 4 and 5. Okay, so this means mu is in between 4 and 5. Now this is, we call this square brackets as the closed brackets. Hope you know this one. This is closed brackets. Closed brackets. So that means we can take the values also in the interval. For example, now here 4, 5, we can take mu as 4 and 5. So if we use this open bracket, so we call this one as open bracket. Open bracket. So if we take mu is in between 4 and 5, so we cannot take this lower and the upper bound. So that means 4 mu is, sorry, so we cannot take this equal sign here. So this means simply, so these are from the math actually. So mu is in between 4 and 5. Okay, so that is the meaning of this open and the closed brackets. So anyway, now here, so if we are considering this kind of interval estimation, we understand, okay, so we have kind of a range of values that we can take for mu. Simply mu is in between 4 and 5. Now here you see this 4.5, this point estimation is also inside this interval estimation. Okay, so usually that's the case. If we find a kind of a if we consider, I mean, this point estimate, this single value is should also be inside this interval estimation. Okay, now, yeah, so now here we are considering kind of interval estimation. Basically, in this class, we consider the interval estimation for mu and sigma. Mu and p proportion. Mu and p. Okay, so mu, we use mu for the population mean. And capital P, this is capital P for the population proportion. Okay, these are the two parameters that we consider in this class, in your class. These are the two population parameters. Now, mu, we have already covered the confidence interval estimation for the population mean. So we discussed this confidence interval for population mean based on two cases where sigma is known, sigma is unknown. Okay, so let me erase this one here. Sigma is known and the sigma is unknown case. Okay, so we have covered this part actually, but I will quickly go through this one again, and we are going to discuss this one now. Population proportion, how to find a confidence interval for a population proportion. And let's quickly go through finding confidence interval for population mean when sigma is known and sigma is unknown. Now sigma is the standard deviation. Okay? So basically you need to remember the formulas here. Okay. So confidence interval, I hope you understand that part. I explained this one. So now let me directly jump into the, basically confidence interval. So we are confidence interval means we have some kind of a confidence level, let's say 95%. So we have 95, we are 95% confidence that the values are in between these two. Okay, so that's where we are having this confidence part. So basically, the confidence interval contains two parts, point estimate plus or minus margin of error. Won't the formula be given? No, no. For this first module, we don't give any formula that way. Okay, formulas, you need to kind of remember those formulas. So now, yeah, confidence interval contains two parts. Point estimate. Now you see here why we are having the point estimate inside of the confidence interval, because we derive this confidence interval around the point estimate. Okay, so that's why we always have the point estimate inside whatever the confidence interval that we calculate. Okay, so the general form of confidence interval is point estimate plus or minus margin of error. Okay, so let's see what's the margin of error when we want to estimate confidence interval for a population mean and the population proportion. So yeah, let's go with the confidence interval for the population mean. So this is the confidence interval for population mean when sigma is known. Sigma is the standard deviation of the population. Okay, so so this is 100 times 1 minus alpha. So alpha will be given. So usually the alpha will be 5%. So this is the error. So I explained this one. This is the error that we make, 5% error, or this can be 1% error, 10% error, okay, depending on the value that you are given, we can find the confidence interval. Now, if we have 5% error, that means we have 95% confidence interval. If we have 1%, so that means we are deriving 99% confidence interval. If we have 10% error, then we have 90% confidence interval. Okay, so depending on the alpha value, we can find the corresponding confidence interval. Now, we will discuss this one. We will discuss more details about this error on the topic. I mean, in the topic that we are going to discuss today. So you will understand how we are making this error and what is kind of the real meaning and so on. So anyway, so this 100 times 1 minus alpha confidence interval for mu when sigma is known, we have this X bar. So this is the point estimate. This is that point estimate. And this part is simply the margin of error. Margin of error. Okay. So you see we have point estimate plus or minus margin of error. Now when sigma is known, here you see we use Z distribution. We use C distribution when sigma is known, and here we have the sigma. Okay. So we can write the same thing with this plus or minus thing as a kind of a using this less than or equal sign. So we have this negative sign on the left hand side. This is the lower bound of the interval, or lower limit, you can say. And this is the upper bound. You know, when we have an interval, we have lower limit, lower bound, or the upper bound, or lower limit or the upper limit. So this is the upper bound or the upper limit of the interval. Okay. So lower limit, we have the negative sign. Upper limit, we have the positive sign. Okay. Yeah. So this C, this is the critical value of the standard normal distribution for an area of alpha over 2 in the upper tail. Okay. So this part we need to find from our Z table. I hope that's clear to you as well. I will again quickly go through one example. So now, yeah, confidence interval when alpha is 5%, 0.05 means 5%, where then the confidence level. So this is the confidence level. CL means the confidence level. This is confidence level will be 95%. Okay. So this part is also clear to you. Okay, then, yeah. So the margin of error is this part. Okay, so and so this part, I guess Miss Uttara has already discussed, but I will quickly go through this one. Now this mu, this m, we see, I mean, we understand this m will or m decreases when the confidence level decreases. So the confidence level decreases means this critical value decreases. So the critical value gets smaller. So that means this gets smaller, this z. So when z gets smaller, we see the m gets smaller. Then we see now when sigma gets smaller, m again gets smaller. But as now n, the square root n is in the denominator, we see when n gets larger, this m gets smaller. Okay, so you can simply look at what happened to m when these critical value gets smaller, sigma gets smaller. I mean, so depending on whatever the value that we have, we can compare the, I mean, let's say we have two sets of z, sigma, and n. Then based on those two sets of values, we can say something about this margin of error, whether it gets smaller or larger. Okay. So then I hope you have already, we have already discussed this question. So yeah, so simply what you need to find a confidence interval, we need to find first the margin of error here. So because this is the confidence interval for mu will be x bar plus or minus our margin of error, okay, m, capital M. So the m will be simply the z alpha over 2 times sigma over square root n. Okay, so x bar is given, sigma is given, n is given, but we need to find this z part. So let's see how to find that z now. So we are finding a 95% confidence interval. 95% confidence interval means simply alpha is 5%. You can directly kind of get the difference between 100 and 95. Therefore, the alpha will be 5. Then alpha over 2 will be 2.5%. Okay, so this part you can find. Now, let's say if alpha is 10%, then alpha over 2 is 5%. Okay, you can find that one. Now, let's see how to find this, this critical value, this z. So we call this one as the critical value. If you go back to the definition, yeah, this is the critical value of the standard normal distribution for an area of alpha over 2 in the upper tail. Okay. So what we are going to find here actually, if we draw our standard normal distribution, so let's say this is our standard normal distribution where we have mu as 0. Okay, this is our z distribution. So simply what we need to find the critical value of the standard normal distribution in the for the area of alpha over 2 in the upper tail. Okay, upper tail is this one. So this the area under this or the area of this region will be now alpha over 2. Alpha over 2. So simply if we have 95% confidence interval, this will be 2.5%. Okay. So this is the critical value that we need to find. This is the value that we need. Okay, so we denote this one as z alpha over 2. So we need to find this z value. Okay, now let's see how to find this z value from our z table. Okay, let's go back to the z table. Yeah, okay. So now So this is our Z table. Now here, the area is 2.5%. So that means this is 0.0025. And if you look at this, our usual Z table, so let me erase this one. Z distribution or the Z distribution, if you look at this diagram, you see in this table, we are having the right-hand side area. Okay, so this blue color area. Okay, so therefore, if you want to find the Z here, if you want to find the Z in the upper tail, actually we need to consider this left area, left side area. Okay, simply let me use another color here. So simply we need to consider this red colored area. Okay, now if this is 0.025, 0.0025, if this area is 0.0025, then this will be 0.9725. Okay, now how do we find the corresponding Z value here? So we need to look at where we have this 0.9725. So 9725 is 9725 is actually somewhere here. Okay, somewhere here. Yeah. So this is actually this is 9.9726. Okay, 9726. Sorry, that one. This is not 972. Okay, so that's my mistake. So this should be, sorry, this is, that's why I was looking at, okay. So this is actually, this should be, no one commented. Okay, no one has commented whether this is correct or wrong. Okay, so this should be 9, this is actually, so how do we find this one? The 1 minus 0.0025. This is actually 9975. Am I? Let me check. Yes, correct. Yes, that was 99. Yeah, it should be 997. Wait. So we are considering. Let me go back to. I'm considering. Yes. Okay, yes. Sorry, it's my mistake. Completely my mistake. This should be. Yes. Sorry, that one came on my Okay, so this should be 0.025. Okay, so 2.5 means 2.5% means yes. Sorry, yes. Correct, Daruni. Thank you for your comment. Yes. Thank you so much. Yes, yeah. Maths, I'm also kind of confusing. Okay, converting the percentage into the decibel numbers. Okay, so this 2.5% is 0.025. So simply, this is mistake. Okay, so thank you guys. Okay, so this should be 1 minus 0.025. So this is basically 0.975. Okay, 0.975. Okay, now we are looking at where we are having this value. Inside, or where we are having, we are looking at the cell values. Okay, we are looking at the inside of this table. So 975. So 975 is somewhere here. This is the value. Okay, so we are having, so this is 0.975. Then we should read the corresponding Z value. So, I mean, in the first part, in the first module, first topic, under the sampling distribution topic, we know the Z and then we look at the area. But in this topic, when we are finding critical value, so these Z are the critical values, these Z values are the critical values. So what we do, we know the area, now we are finding the Z value. So therefore, we need to kind of go backward, okay, or read backward. Now, what is the value actually? What is the corresponding Z value here? So 1.96. So the corresponding Z, this C, we use this notation, Z alpha over 2 will be 1.96. Okay. So then now we can use that value to kind of calculate our confidence interval. So here you see we have the Z 9.16, 1.96, and we can plug in, we plug in the other the values and we can find the margin of error. Then we can use that margin of error to find the confidence interval. Simply the point estimate. So here simply we have X bar, that is the point estimate, plus or minus margin of error. Okay, then you can take the lower limit with the minus sign, upper limit with the plus sign. Okay, then how do we interpret? We interpret the interval as we conclude with 95% confidence that the population mean of the college students having funds, blah, 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 is between these two values. Okay, or you can say, okay, we are 95% confident that the population mean of blah, blah, blah is between, is between these two values. Okay, these two values. So that's how we find or we calculate the confidence interval for mu when sigma is known. Now let's look at the next case when sigma is unknown. Okay, so you can try this question. I hope you have already tried. If not, please go through these exercises as well. Okay, very simple one. Where there's nothing new, just you need to find the margin of error, then construct confidence interval and interpret. Now here we are having 99% confidence interval. Okay, let's see how to find the Z. Now here 99% confidence interval, Darune. So 99% confidence interval means we have alpha. Simply alpha will be 100 minus 99. So it will be 1%. So therefore, alpha over 2 will be 0.5%. 0.5%. So then if we quickly draw our Z distribution. So here now we have the area will be now 0.0050. So therefore, we need to consider this area to use our Z table. Simply this area will be 0.9950. Okay, 9950. 9950. Now so this will be our Z alpha over 2. Now let's see how to use our table. So 0.9950 somewhere here. 9950. Where is that one? Yeah. So 50 is in between these two values. Because this is 9949, this is 9951. Yeah, you can take whatever the value. You can take this one, or maybe or the Z value corresponding to this value or corresponding to this value. So let's take 99449. Okay, so let's take that value. Okay, so the Z value will be Z value will be so this C value will be simply 2.57, or someone can take 2.58 as well. Sorry, can we also take it as, what do you mean? Can we, I have a question, Daruni. Can we also take it as 2 point? Question can we also take it as 2.5 and take, you mean taking the average of these two values, 2.57 plus 2.58, Daru? Is that what you're asking? Yes, yes. 2 point, that's what you're asking, right? Since, yes, yes, yes. Yeah, you can take that average as well. Yes, yes, yes. You can take the average of these two values as well. Yes, fine. That's fine because this 0.9950 is in between these two values. Yes, but usually the thing is now here you can take the average, Daru. I mean, it won't. I mean, it doesn't change the whatever the lower limit and the upper limit that much. Therefore, you can take. But the thing is now here you see. Now you see here. So 0.9950 is in between 0.9949. 0.9951. And now if you look at the difference here we have kind of the difference between these two values is 1, and here also 1. But the thing is, now let's say we have, let's say we have here 99. Now the difference is 1. Okay, now, so if we have this kind of the case, so we have sometimes this kind of the case. So then it's not that much accurate if we take the average of these two values, because now here the difference between these two values 3, here the difference is 1. So therefore taking the average between these two values will not be that much accurate. ඒක නිසා තමයි better to take just the value, just read the Z value which is close to this whatever the considered value. But we can find exact value using our R or using Python. This table gives us up to only kind of 4 decimal points. Better to kind of consider just a value which is close to the a given area. Okay. I asked just in cases where the difference is equal. Yes, yes. When the difference is equal, yeah, yes, Darua. I'm the others I'm explaining kind of. I think I'm explaining to Situ. Maybe I don't know. I cannot find your Situm. No, I don't know. I don't know your first name, but anyway, I hope it's clear to you. Yes, when we have a kind of a equal kind of the difference, when the difference is equal, then we can of course use the kind of the average. But when the difference is not equal, then better to go with the value which is closer to the given age. Okay, but we can find the exact value using R or Python. Right? So I was explaining the kind of the answer, or I was giving an answer for a question that one of your colleagues asked. Okay. Anyway, so I hope it's clear to you now. This will be so we can consider 2.57 or maybe 2.58 as well. Okay. So then let's go back to our slide. So yeah, using that Z, you can find the margin of error and the confidence interval. Okay. Okay, so let me erase this. Now then let's see, let's go to the next one. Then the confidence interval for mu when sigma is unknown. Now you see here the difference when sigma is known. When sigma is known, we use the margin of error as d alpha over 2 sigma over square root 10. Now when sigma is unknown, the margin of error is, this is m, this is the margin of error. Now instead of c, we are using another distribution called t-distribution. So for a t-distribution, simply we have a kind of a parameter called degree of freedom. Okay, so this is the degree of freedom parameter. And we have the alpha over 2, similar to the z part. And then instead of sigma here, now we have s. That is the only difference. Okay, so when sigma is known, we have z and sigma. When sigma is unknown, we have t and s. Now, s is actually the sample standard deviation. When sigma is known, we can directly use sigma. This is actually the population because we know the population standard deviation. So when we don't know the population standard deviation, we discuss instead of population, we can use the sample. So that's why when we don't know or when sigma is unknown, then instead of sigma, we use s. Okay. Similar to that, similar to the previous case, we can find the lower and the upper limit. So this, now here, we call this part as the critical value of the t-distribution with n-1 degrees of freedom for an area of alpha over 2 in the upper tail. Very similar to our z-distribution. Now this is, let's say this is our t-distribution. We again consider, so t is also distributed around the mean, around 0, not mean, around zero value. So what is the area that we are considering? It's the area in the upper tail, the area of alpha over 2. So this will be alpha over 2. So we need to find this t value. We use this notation n-1 alpha over 2. N is actually the sample size. Okay, n sample size. So then let's go to the next slide. Let me erase this one quickly. If you have any question, please stop me and or you can type your question in the chat as well. Okay, please ask questions, Darwin. Okay, so this is the t-distribution. So you see, this is very similar to the kind of the standard normal distribution. It's a bell-shaped curve again. It's symmetric curve. So we usually denote t with this degrees of freedom. Here we have k degrees of freedom. Anyway, now you see here when the degrees of freedom increases, we have kind of now here we have the red color one. We have degree of freedom 5, and the blue color degree of freedom 30. Now you see when the degree of freedom increases, we have kind of a peak here. Okay, kind of a not kind of a flattered kind of a peak. So here we have a bit of kind of a sharp peak. When the degrees of freedom goes to infinity, we have a very sharp peak here, but the curve is symmetric and it's a bell-shaped symmetric curve. Okay, and we have kind of a fatter tails as well. Okay, fatter tails as well, depending on the degrees of freedom. So this is symmetric around 0, t-distribution. Okay, so similar to the our standard normal distribution table, we have a t-table as well. So this is the t-distribution. Okay, t-table, we call this one as the t-table. So here you see, if you look at this graph, we have on the first column, in the first column, we have the degrees of freedom, 1, 2, up to 1000. Okay. there are some missing degrees of freedom, doesn't matter. But anyway, we have the degrees of freedom here in the first column. And in the name, the column names will be, if you look at the column names here we have the probability value. Okay, upper tail probability value. Okay, so this will be, so upper tail probability here, this is the probability that we have here, upper tail probability. So here we have 25%, right? 20%, 15%, 10%, 5%, 2.5%, likewise. Okay, so these are the probabilities, the upper tail probabilities we have. Okay, this is very simple. When we are using the t distribution, we need to simply look at the degrees of freedom and the corresponding the upper tail probability, and then we can directly find the t. Okay, for example, let's say n is 10, n is 10, alpha is 5%. Alpha is 5%. N is 10. Huh? So then we know n minus 1 will be 9. Then alpha over 2 will be 2.5%. Okay, 2.5. So the t n minus 1 will be, then we need to find t9 2.5. So we need to consider the corresponding degrees of freedom. That's 9. Okay, so 9. And then 2.5% is this column. So what will be the corresponding t will be, then this is the value. The value. So t will be, so the critical value will be, now in the t table, you should understand the critical values are inside the table. Okay, critical values are inside the table, but in the our z table, critical values are in the critical values are critical values are given as the row names and the column names. Okay? Yeah, so here we have the critical value inside the table, so that so t, this value will be 2.262. Okay, now let's say if we have n as 15 and alpha as 10%, so we need to find t14 5%. Okay, because alpha over 2, then we need to consider this column, and the 14 will be n minus 1 is 14. So this is the value we need to consider. This will be our t value. Okay, so the t value will be 1.761. Okay, so likewise, you can find the corresponding critical value. Okay, these tables will be given, so you don't need to remember anything here. Right? So I hope it's clear to you now how to use the t table. Yeah, basically these are the two tables that we use in this class, t and the z table. We don't use other distributions. You will use those ones in the second course. Yeah, but for this course, we are only using these two tables. Right? Okay, so it's clear. Then let me erase everything and then move to the next slide. Okay, so then, yeah, so this is the kind of the question. Now here, if you read this one, I hope this also kind of covered, already covered this question. So a sample of 15 weekly reports. Now you need to kind of write or kind of extract the corresponding or the relevant values. So sample of 15 weekly reports. So that means we know n is 15 now. And the sample mean is given. That means x bar is given 19.5. And the sample standard deviation, that is S, is also given 5.2. Then we need to find 95% confidence interval. Okay, so 95% confidence interval we are going to derive. So, yeah, so here we have all the given data. So now to find 95% confidence interval, now here you should understand, okay, sample standard deviation is given. So therefore, we need to consider the confidence interval for mu when sigma is unknown. So therefore, we need to use the t distribution. So here everything is explained how to find the corresponding alpha and the n-1. So you can read this value or get this value from the table. Once you know the value, you can find the margin of error and the confidence interval. And you can see how to interpret the corresponding confidence interval. Okay. Okay, so that is the part that we covered last week, and this is for you to practice. So try to do that one and try to do the quiz as well. Okay. Now let's discuss the confidence interval for the population proportion. Now, if you remember the kind of the explanation that I have discussed with you last week. So basically the population proportion, when we are discussing the population proportion, we basically have kind of, basically we consider a question where we are having two options. For example, I think I consider this question, do you like ice cream? And we have only kind of a two binary kind of the two options, yes or no. So here we have kind of a binary option, yes or no. So, or success or failure. Success usually comes with yes, and this one failure. Okay, so this population. So simply the population divided into two parts, yes, I mean the values with yes and the values with no. Okay, so now here, so you see we are having a kind of a binary case here. So we can simply calculate a proportion P. So for the population proportion, we use this capital P. Okay, then the sample proportion, we use this simple P hat. Okay, you know, we can take a sample out of this population. Then sample also contains simply two situations, yes and no. Okay. Then this population proportion of success. So usually P comes with the success part. Okay. So this is simply the probability y equal 1. Okay. Probability y equal 1. Y is the success. Okay. Let's say this is y equal 1 and y equal 0. Okay. 0 with the no option, 1 with the yes option. Okay. So when we take a sample, we can calculate again the proportion of success based on the sample data. So now what we are going to do, we are going to find a confidence interval for P. So we are going to find upper and the lower limit for this population proportion, similar to the mean. Okay, so yeah, let me erase this one. So with the categorical data, we want to estimate proportion of items in the population having a certain characteristic of interest. So let P, capital P, it's an unknown value because it's why it's unknown, because it's related to population data. Usually we don't know the population value, so the population parameters. Okay, so that's why we are considering this capital P. One moment. I think it's Dr. Thirukan. Yeah, anyway, it's okay. Hi. So let capital P be the unknown population proportion, and simple P hat, it's a sample proportion, and that is the kind of the estimate. So we use this P hat. Simple P hat will be the value that we estimate using sample data. Okay. So then p hat will be, we can simply calculate our sample proportion as x over n. X is the number of items in the sample having the characteristic of interest, and n is the sample size. Simply the proportion of subs. Okay, proportion of subs. So then once we know the proportion, that p hat, we can calculate our confidence interval for the population proportion. So here again, we have this p hat. Okay, this is the point estimate now. This is the point estimate. And this part is simply the margin of error. This is M, margin of error. It's given here, margin of error. Okay. So Z, now here we are using Z table, Z alpha over 2 times this part, this square root part. Okay. So we are using again the critical value of the standard normal distribution for an area of alpha over 2 in the upper tail. Okay. Now there's a condition that we need to check when we want to kind of derive a confidence interval for the population proportion. So here n, the simple n or the sample size must be large enough to ensure that to use this confidence interval, n must be large enough to ensure that both x and n minus x are greater than 5. So we need to check whether x, this is the number of, this is x is the number of success, let's say success items in the sample, n minus x is then number of failure items actually in the sample. So these two values, x and n minus x, should be greater than 5. Okay, if this condition is kind of satisfied, then we can simply derive a confidence interval for the population proportion. This is population proportion. Okay. Now let's go to an example and see. Okay. So here we have in a survey of 1,200 social media users. Now let's kind of summarize the values we have. So we have 1,200 social media users. So we have 76% say it is okay to friend co-workers, and okay to friend. Okay, and we have 56% said not okay to friend your boss. Okay to friend here co-workers. Okay, we have simply two questions actually. Okay, so the first part is friend co-workers. The second is to friend your boss. So then find the point estimate of the population proportion of the social media users who would say it is okay to friend co-workers. So P. So we need to find the point estimate, that is the P hat, simply by looking at the value you say. Now here we have a survey of 1,200. This is simply kind of a sample. So simply P hat will be 0.76. Okay. From the whatever the given value, we can say, okay, the sample proportion of the social media users who would say it is okay to friend co-workers will be 0.76. Then we know, then we can find the confidence interval. We need to find the margin of error and find the confidence interval. Okay, so let's go to our solution. Okay, now you see here. Okay, so this is the point estimate, that is 76%. Okay, and we need to check these two conditions. Here you see, I have checked x and n minus x greater than 5. So x will be simply, now, you know, x will be 1200 times our 67%, because you know, we can calculate p hat at x over n. Okay, so therefore x will be n times p hat. Okay, this is n times p hat. Okay, definitely this is greater than 5, then n minus x again greater than 5. So those two conditions are satisfied. So therefore, then we can quickly calculate the confidence interval. Point hat, p hat we know, it's from our data. And then we can calculate margin of error. Okay, so it's we need to find the z value. We know, you know now how to find the z value, 1.96, and plugging the whatever the p hat values, which is inside the square root, and then this will be the confidence interval p hat plus or minus the margin of error. Okay, then this will be the confidence interval. So then we can say, okay, we conclude, or we are 95% confident that the population proportion of social media users who would say it is okay to friend coworkers is between these two values. Okay, so you can simply kind of interpret the confidence interval. And simple one. Okay, then there's the question, and there's another question in the previous example, this one. And construct 95% confidence interval for the population proportion of social media users who would say it is not okay to friend their boss. So now you are using this 56% proportion and find the confidence interval. Okay, you can do that one. You can try that one and then try this exercise as well. Okay. And there's another pop quiz on our Moodle page. So this one, so try to do that one as well. And there are practice worksheets as well. Okay. Okay, then the last topic of last subtopic of this confidence interval estimation, under the confidence interval estimation, sample size determination. So here, I mean, this part actually, you can, I mean, you don't need to kind of, well, yeah, this part is also, you will need to kind of remember this small kind of the sample sizes. So sample size determination for mu, simply actually this part comes with the margin of error. Now you know margin of error for the population mean will be d alpha over 2 sigma over square root n. So from here, what we do, what I'm going to do, I'm going to take the square, I'm going to consider square of this both of the left-hand side and the right-hand side. Then this will be sigma squared over n. Now we can find an equation or find a relationship for n. So n will be simply z squared alpha over 2 times sigma squared over m squared. So this is what we have here. Okay. So this comes with the margin of error actually. So if you know the margin of error, then you don't need to remember this is this has a kind of another kind of a relationship. If you know the margin of error for the population mean, then that's enough. And so the margin of error for the population proportion will be d alpha over 2. Now here we have actually p hat, but instead of p hat, to find the sample sizes, we use P times 1 minus P instead of P hat. Let me show that one to you. Now, in the confidence interval for the population proportion, the margin of error here, if you look at this margin of error, here we have P hat. But instead of P hat, to find the sample size, we use P. Okay, so that's the only difference. So instead of P hat, I'm using P, and here we have N. Then again, take the square. Consider the square in the left-hand side and the right-hand side. Then this will be P times 1 minus P over N. And then take N to the right-hand side. We have simply Z squared alpha over 2 P times 1 minus P divided by M squared. Okay, this is what we have. Okay. Now M, this is actually margin of error. Or in the sample size determination, we are given a kind of another name, sampling error. Okay, sampling error. Instead of margin of error, we are giving, or we are considering M as the sampling error. Okay. Please try, or please write these kind of the derivations. Then you don't need to kind of remember this relationship as a kind of a specific kind of the formulas. And if you know the margin of error, then you can simply find the sample sizes. Okay, so yeah. So when determining the sample sizes for mu, we use Z. Now, you know here, when we are kind of considering the confidence interval for mu, we have two cases. Confidence interval for mu when sigma is known and when sigma is unknown. But when we are determining the sample sizes for mu, we are kind of ignoring the situation where sigma is unknown case. Okay, so that's what explained here. When determining sample sizes for mu, we use Z table instead of T, because to determine the critical value for T, we need to know the sample size. Okay, now, because you know, if you are using the T distribution, we have this critical value Tn minus 1 alpha over Tn minus 1 alpha over 2. Now here, we should, to find this n minus 1, we should know the sample size. But we don't know. That's what we are going to kind of actually determine. So therefore, that's why when determine the sample size for mu, we ignore that sigma is unknown case. So therefore, we simply use Z instead of T distribution. Okay. So now, now the thing is, we know now to kind of determine the sample size. If we go back to our relationship, now we see here we have this population parameters. This sigma, it's the population standard deviation. This capital P is the population proportion. We don't know those population parameters, but so yeah, not that we rarely know the population parameters. So then how do we find those? That is the case. Okay, so in some cases, we have the past data, or from our relevant experience, we can actually estimate those parameters. Okay, I mean, we know instead of our population standard deviation, we can use the sample standard deviation. instead of the population proportion, we can use the sample proportion. We can estimate those parameters from our past data, or we can, if you have some experience, relevant experience, then we can use those ones also to find the parameters. But if we don't know the past data or the relevant experience, we don't have the past data or the relevant experience, then we can provide some values for the parameters, but the thing is that will kind of underestimate the sample size we need. Now, if we just get some values, or if we use some guesses for the parameters, for the population standard deviation and the population proportion, then that would underestimate the sample size we need. But anyway, we can, I mean, depending on some experience we have, we can guess some values for the parameters, and we can use those to determine the sample size. Yeah, so for example, to determine the sample sizes for mu, we can estimate sigma. So these are kind of just the rule of thumb. These are the rule of thumbs that we can use to kind of determine the sample sizes. These are kind of useful when you are doing your kind of the projects. So I'm not going to kind of explain this one in detail, because we are here to kind of to simply calculate the sample sizes. But these rule of thumbs will be kind of useful when we are really using this when you want to calculate the sample sizes for your projects. Okay. Yeah. So let me erase and sorry. Yeah. Go back. Yeah. Go. Let's move forward. So determining sample sizes. Two examples. The first one is we are having determining the sample sizes for the population mean and the related to the population proportion, the second one. So we are having 95% confidence. The mean life of light bulbs to within plus or minus 20 hours, and we are having the standard deviation 100 hours. So let's see how many light bulbs that we need to select. So here alpha is given. Here alpha is given. It's 9. I mean, we know the confidence interval. Confidence interval will be 95%. Not 95% confidence level, not the interval, confidence level. So therefore alpha will be 5%. Then we can find alpha over 2. It's 2.5%. Then we can find the z corresponding critical value. It will be 1.96. And then we can find, we can use the sample size formula. It's this one. Then just plugging the values, because sigma is given here. Population standard deviation is given here 100, and this is the sampling error, or the M, or the margin of error. Plus or minus 20 is the margin of error. Okay? So 20 squared, and then we round this number to the next whole integer. So simply this is 97. Okay, so we need 97 bulbs for that problem. Okay. Then for the proportion, here we have 66 will be the population proportion, and 99 will be the confidence level, and here we have the margin of error. So simply plugging those relevant values and then round the value to the nearest whole integer. Okay. So likewise, you can calculate the sample size. Okay. Okay, so we took around 1 hour to kind of, not 1 hour, yeah, 1 hour and 20 minutes to kind of cover the last topic. Now I'm going to move to the next one where we are going to discuss the, where we are going to consider the hypothesis testing. Okay. Hypothesis testing. So here what we are going to discuss, now you know, simply we have population, that the bigger one. Okay. Then we take a sample out of this population, subset simply. Now what we do, now let's say we are having here, let's say we have population parameters as mu, population mean, simply the population mean. So now we discussed actually, we already discussed two methods, point estimation. That means we try to find a value, a single value for this population parameter, population mean, and then we have already covered the confidence interval estimation to say something about our population mean. So simply here we find kind of an interval where we are having the lower limit and the upper limit. Now the third method that we are going to discuss, or that we are going to consider to say something about the population parameter, is the hypothesis testing. Hypothesis testing. Here also we are going to say something about our population parameter in a kind of a different way. Basically, using some kind of a testing procedure, we are going to say something about this population parameter. Okay, so there is a kind of a couple of steps that we need to consider when we are using this hypothesis testing to say something about our population parameter. Okay, I hope it's clear to you the differences between these three methods. Now what we do, so we have a population and we take a sample. Now using this sample data, we are going to say something about the population. That's what we are going to do. So all three methods actually comes under the inference, statistical inference or inferences. Or statistical inference, let's say. Statistical inference part, because we are going to say something about our population parameter using the sample data. Okay. Well, it's going to have a heavy rain here. Okay, let's see. I will do the session until power goes out. Okay. I'm not sure because I'm using my Wi-Fi. Anyway. So, hypothesis testing. So, let's see what are the topics that we are going to cover under the hypothesis testing. So, we are going to simply discuss these couple of topics. Null and alternative hypothesis, what's the meaning of one-sided and two-sided test, and the testing procedure, and the errors. So under these errors, types of errors, we will discuss that alpha part, okay? The alpha, the error that we have discussed, that we have considered in the confidence interval estimation. And we are going to discuss one sample test based on a one sample, the testing procedures that we can use when we have just a one sample. Then you will discuss the extension of this test in your second stat course and in machine learning course and multivariate analysis course and so on. You will discuss a wide range of tests as the extension of this test. Okay, so you need to have a very good understanding about this hypothesis testing and also the one sample test. So here we are going to discuss basically a test about the population mean and test about the population proportion. Okay, because we are using only two population parameters, population mean and the population proportion. Okay, so today during this last 45 minutes, not 45, last couple of minutes, I'm going to kind of give you the basic of the hypothesis testing. So let me erase that one. Yeah. So in this lesson, we are going to study the basic principle of hypothesis testing, and the other part, I hope we will not, the time will not be enough to discuss the other topics, but we will cover the basic principles or the basics of the hypothesis testing too. So let's look at what's the meaning of the null and the alternative hypothesis. Let's see this example. So there's a manager who claims that the average waiting time to receive an order is 12 minutes. But let's say we believe that the actual average waiting time is a bit higher than this 12 minutes. So therefore, to check whether the manager's claim is actually correct or incorrect, what we can do, we take a random sample of customers and we try to calculate that sample mean waiting time. So then what we have, depending on the random sample of customers we have the sample mean waiting time as 14.5 minutes. Now you see here, if you look at these two values, these 12 and the 14.5, simply these are two different. The values are not the same. The manager claims that we have 12 minutes as the waiting time, but when we consider sample, we have the mean waiting time as 14.5. So if we use this sample mean, and if you are going to say, okay, so this means that the claim of this manager is wrong. So by now this is 14.5 and this is 12. So we see there's the difference between the values. So that doesn't mean, so does this mean that the claim of this manager is wrong? We can't just say, by considering this sample value, we can't just say, okay, so the manager's claim is completely incorrect. We can't say that. So that's what now, so using this hypothesis testing procedure, so we are going to really check whether using this, whatever this sample data, we are going to check whether this manager's claim is actually correct or incorrect. Okay, using this sample data. So to do that, we need to kind of define two statements. So these statements will be the null and the alternative. So let's look at this hypothesis testing part. So the formal procedure in which we use sample data to test the plausibility of hypotheses about, so we can use a kind of a testing procedure where we use the sample data to say something about our one value of a parameter, or we can use the hypothesis testing when we have several parameters, and we can use this hypothesis testing if we want to kind of say something about the population distribution. So simply, we can use the hypothesis testing procedure if you want to say something about a single parameter, or if you want to say something about several parameters, or if you want to say something about the entire probability distribution. But in this class, we are going to kind of use the probability or this hypothesis testing if you want to say something about just a single parameter. But when you go with the other modules, you will see how to use the hypothesis testing procedure when we have several parameters, or hypothesis testing when we want to say something about the probability distribution. Okay, so now when we are considering this hypothesis testing procedure, we have two statements. Simply, we have two statements. The first one we call two statements. Those statements, we call those one as the hypothesis. We have null hypothesis and the alternative hypothesis. So we simply test against these two hypotheses. Okay, so let's look at those hypotheses separate. So the null hypothesis, we denote this null hypothesis by H0. H0. So this is the claim that is assumed to be true. Okay, so this is the statement that is assumed to be true. Then, so under this hypothesis testing, we reject the null, or null will be rejected when the sample data provide contradictory evidence. Okay, so if the sample data provide enough or substantial contradictory evidence, then we reject the null. You will understand when we are discussing, when we are coming to the problems, then you will understand these 4 steps. Okay, just try to listen, and then you will understand how to use this one, how to use this, whatever the kind of the, how to kind of say whether we are rejecting the null or not based on okay, so it's I guess I'm having a kind of a really heavy thunderstorm, so better
Recording stopped.
let me stop that one. I'm not sure because I'm using Wi-Fi, so I'm not sure what will happen. So let me stop here. Yeah, I will go through this one when we meet physically next week. Yeah, so let's stop here. Don't want to get hurt myself. So yeah, so let's stop. I will anyway upload the recording. Please now next week in the tutorial class, during your tutorial class, you will have a quiz. I will remind that one. I will anyway remind you again. Yeah, so let me stop and then you can enjoy your rest of the evening. Okay, thank you, Darwani. Yeah, thank you.